Today we will continue with chapter number 2, units and measurements. Example 2.8 till 2.7 we have already completed. Now we will see example 2.8. The temperatures of two bodies measured by a thermometer are T1 is equals to 20 degrees Celsius plus or minus 0.5 degrees Celsius and T2 is equals to 50 degrees Celsius plus or minus 0.5 degrees Celsius. Calculate the temperature difference and the error therein. तो यहाँ पे हमें टेम्परेचर डिफरेंस फाइंड करना है और उसमें एरर्स यहाँ पे प्लस और माइनस 0.5 डिग्री जो है वो हमारी एरर दी गई है और T2 में भी सेम है। तो हमें टेम्परेचर डिफरेंस फाइंड करना है। तो टेम्परेचर डिफरेंस द टेम्परेचर difference T is equals to what it will be T2 minus T1, right? So here our T2 is 50 degrees Celsius plus or minus 0.5 degrees Celsius minus what is our T1 20 degrees Celsius plus or minus 0.5 degree Celsius. So यहाँ पे 50 minus 20 it would be 30 degrees Celsius and here see if we will take plus 0.5 and here minus sign, so it will be minus plus minus and here we will only take the maximum error. So maximum error in this would be plus 0.5 and plus 0.5. So both when we will add both of them we will get 1 degree Celsius. So here we have considered only the maximum error because if we take the maximum error all the other errors will be considered in it. So here we are taking only maximum error. So 0.5 plus 0.5 we are simply adding it. Right? Now we will see example 2.9. The resistance R is equals to V upon I where V is 100 plus or minus 5 volt and I is equals to 10 plus or minus 0.2 ampere. Find the percentage error in R. So first we will find the percentage error in V and I. So the percentage error in V. So what will be the percentage error? This error upon the absolute value 100 into 100. So this 100 will get cancelled. We will get 5%. Now the percentage error in I. So here our error is 0.2 upon the absolute value is 10 into 100. So 0 will get cancelled and 0.2 into 10 would be 2%. And we know that R is equals to V upon I. So in this V we have 5% error and this in I we have 2% error. So we know that when both of them are in division the errors will be added up. Whether it is multiplication or division the errors are added up. So percentage error in R is equals to 5% plus 2%. So it would be 7%. Now next we will see example 2.10. Two resistors of resistances R1 is equals to 100 plus or minus 3 ohm and R2 is equals to 200 plus or minus 4 ohm are connected in series, A in series and B in parallel. Find the equivalent resistance of the A series combination, B parallel combination, and for that we have to use the relation. For series we obviously know would be equals to R1 plus R2 And for the parallel connection, that is, it would be 1 upon r dash is equals to 1 upon r1 plus 1 upon r2. So first for the series connection we will find. The equivalent resistance for the series combination is R is equals to R1 plus R2, and here we have R1 as 100 plus or minus 3 plus our R2 is 200 plus or minus 4. So here again we will add the absolute value 100 plus 200, so it would be 300, and here again, as I have told in example 2.8, we will take the maximum error, so it would be plus or minus 3 plus 4, 7 ohm, right? Unit is necessary to be written. So here what we are getting equivalent resistance as 300 plus or minus 7 ohm, right? Now we will find the equivalent resistance for the parallel combination. The equivalent resistance for the parallel combination is, see, for parallel we have formula 1 upon r dash is equals to 1 upon r1 plus 1 upon r2. So for this we can write r2 plus r1 upon r1 into r2. Here r2 we have cross multiplied simply. 1 into r2 will be r2 plus 1 into r1 will be r1, and upon r1 into r2. Now here we have 1 upon r dash, but we need to find r dash. So what we will do, we will take reciprocal of it. So 1 upon r dash will become r dash, and r2 plus r1 upon r1 into r2 will become r1 r2 upon r1 plus r2, right? So now we will substitute the value of r1, we have 100, r2 we have 200 upon r1 plus r2. That would be equals to 300. 200 plus 100 would be 300. 0 0 cancelled. So 200 upon 3. So for that we will get 66.7. When we will solve 200 upon 3, we will get 66.7 ohms, right? Now we will need to calculate the error. See, here it was simply addition, so we have just added up the errors. But here first we have found out the absolute value, now we will find out the error. And for that we are given the hint. What is the hint given? Delta r dash upon r dash square is equals to delta r1 upon r1 square plus delta r2 upon r2 square, right? So from that we need to find out delta r dash. So delta r dash, we will multiply this r dash square here. So it will become r dash square upon here, see, for this also delta r1 as it is and r1 square. So we can take r1 dash r dash upon r1 whole square into delta r1 plus this r dash square will be multiplied in this term also. So it will be delta r dash upon R2 whole square into this delta R2. I have just rearranged the terms so it would be easy to square because both of these terms are in squares. So I have taken it as division and then we have to square it only once. Right, now we will put the value of R dash. What is the value of R dash? We have obtained it here, 66.7. So 66.7 upon R1 is 100. So whole square into delta R1. So here delta R1 in question it is given 100 plus or minus 3. So delta R1 is 3 into 3 plus R dash again 66.7 upon R2 is 200 whole square into delta R2. So it is 200 plus or minus 4. So delta R2 will be 4. So into 4. Right. Now upon solving this we will get the answer 1.8. So our delta R dash is 1.8. So our equivalent resistance R dash with the error would be 66.7 plus or minus 1.8 ohm. Right? Thank you.